Back to some more PDEs. Um, this is almost just like example 1, except the h of x is on the bottom boundary instead of the top boundary. And let me tell you, it makes just that little change makes the problem so much harder. You would think, oh, it'd be the same answer. Well, you would think so. It's a symmetrical, well, kind of symmetrical rectangle. Well, I guess it is. It's like, oh, wouldn't it just be the same answer? Let me check if it is the same answer. It is. Wait, it is the same answer. But the method to get there is so much harder. Yeah, it is. So let's, excuse me, we know how to solve for lambda n and s of n. It's the same thing, but we might as well draw it out. We don't have to draw it out, to be honest with you. No, we could. It's useful. Let's draw it out. Let me make that straight. Bam. U0y. This is 0. This is a. So just like the last problem. U0y is 0. You have ay is 0. You have x0 is hx. U of xb is 0. So you can see it's the same exact problem, just this and this are flipped. This and this are flipped. And they're using h of x instead of g of x. The only difference. So you do end up with the same answer, it looks like. Just the method of getting there is, you gotta do some really annoying stuff. So from the last problem, steps 1 and 2 are the same. Oops. As in, yeah, let me write it out. In example number 1, left us with eigenvalue of this and an eigenfunction of this. Remember, this is for n equals 1, 2, 3, and so on. Next part would be to solve for y. Given the second equation, which was, and in this case, we don't have y of 0, we have y of b equals 0. That changes everything. Everything. Makes it so much harder. I'll tell you right now, for some reason, this problem is so difficult. For some reason, for people to figure out, because it's like you don't expect it coming. It's the only kind of problem that's like this for Laplace, by the way, that I know of. I'm not sure about the side boundaries. It might be the same kind of. Yeah, it probably would be the same deal with y of a equals 0. Yeah, probably. Subtle foreshadowing. Yeah, let's go ahead and solve it. This this will go over, become negative. We're left with plug that in. N squared pi squared over a squared. Kind of squeeze that in down there. General solution. That's negative. Okay, sorry, I just rewrote that. So then y of b would be, because now we're using the initial condition, c1e to the n pi over a b plus c2e to the negative n pi over a b. Like I said in the last video, we now can't directly solve for c1 exactly because, you know, as you can see here, what we could do, well, we could do that, but it's going to be in terms of all that e stuff. So c1 would be equal to negative c2 times e to the negative n pi over b over a over e to the n pi b over a. That basically equals negative c2, because you move that up to the top, the denominator. And whenever you multiply exponentials together, the numerator, the powers. Oh man, what's the word for it? Oh man. Yeah, the powers, right? The powers, they add the powers together. So it just becomes minus 2 n pi over a times b. Yeah. So then plug it back in for c1, back into the original y. Negative c2, negative 2n pi b over a times e n pi over a times y plus c2 e to the negative n pi over a times y. Right? So now this is, you know, you gotta start thinking. This is where it's like, what in the world? I would have never have thought of that. This took me so long to figure out. I was asking people, I was asking around. I have really smart friends. I was asking, I'm like, how do you do this? And they're like, I have no idea. But I came across a solution somewhere on the internet, I think. Found it somewhere. I remember doing this about a year ago. I was losing my mind. So, the way to do this, so what we're going to do is we're going to divide the whole thing, make it easy on it. There's multiple ways you can get to it, but you can divide by e to the negative. This is what I discovered. This is what I determined on my own time. You just divide by e to the negative pi b over a. Some magical things will happen. So this will become, now for this side, if we divide by this, oh wait, yeah, we're left with negative c2 e to the negative, what would that be? Excuse me. Negative c2 e to the b n a, no, negative b n pi over a n pi b, however you want to write it, times e to the n pi y over a. Right, I just took it out of that first one there. Plus c2 e, and then you just multiply it well, by, see, that's negative at the moment. What we're really going to do is just add 1 to the numerator because it becomes positive, and then you just multiply it by this, and then this becomes, I can move this up into the numerator. Yeah, Make that positive, same thing. I can also, why not? I could denote all these as n like they're supposed to be. So dealing with n's. This becomes negative cn e to the negative n pi over a, took that out, of, I took out a negative, so this is going to be b minus y. Plus e to the n pi over a times b minus y. I took out an n pi over a. B minus, that one's easy. You don't have to take out a negative. And as you can see here, the reason why I did this. Oh, here it is. This is in the form of this one here, right? Just that 2 is there, but you just multiply 2 by sine of h, so then we're left with two sinh of b on the n pi over a times b minus y. Like that. Now, you're like, huh, well, what are we going on here? Well, this is what got me. This is where I was confused. I'm like, how in the world do I incorporate? This is like where I got. This is as far as I got. I was doing it on my own. Then I was like, where do I do with this? This is when I looked it up. This term right here confused me a lot. But then I came to the conclusion after looking at it for like an hour or 2 hours that it's not dependent on y. This term doesn't depend on y. So what does that mean? Well, that means it's just a constant number for every n. But you know what I mean? So it's just like this number 2 here. If you remember the last problem, what we did with that 2, we combined it with the cn. Well, guess what? We can actually do the same thing with this value right here. We can combine it with the cn. I felt like a genius when I figured that out, and I looked it up, and it was right. I was like, no way. But yeah, okay. So yn is equal to cn sinh. Look how much that simplifies it. Isn't that crazy? But yeah, it's really tough to get it into this form, though, I will say. Like, you have to be able to be like the manipulation could take a lot longer. Like, it really depends, and you have to really like look ahead, think about it ahead, and get to it. But like, this is minimal amount of steps, but like on your own, it might have taken like half a page, or a full page or more. You know, now that we're here, the rest of it's easy now. I mean, we got our y sub n, and we know our x sub n. Remember from... Oh, actually, I wrote it down up here. Yeah. Did I write the general solution down? Oh, no, that's the next part. So, that would be step 4. General solution. I'm skipping the fundamental sets. You know how to do that. It's uxy is equal to sum n equals 1 to infinity. C to the n, I remember what it was. Sine n pi over ax. And then we have the sinh n pi over a times b minus y. That's the general solution. Solve for cn. We have that extra sinh in there, so it's going to have to be cn times sinh. Well, so then I'll just divide it by sinh. Remember, we have a Fourier sine series, so we're going to do a odd extension on the h of x to make the whole thing even, because it's an odd times an odd is even, right? This is odd, this is odd, makes an even. You can then expand it this way, go from 0 to a. Alright, I made a bit of a mistake. I'm going to edit this into the video quick. I just, whoops. Here when you're looking at this, I forgot to do the ux 0 equals h of x thing to plug in 0 in for y. When you do that, you're left with the sinh h of b. So you have to divide that by sinh h. Well, you're solving for sinh h times the c sub n times sinh h. So then you divide by the sinh h, which leads you to this. So I forgot about this. So just so you know, in case you were confused, wondering, like I said, I don't know if I said it in the video, but the problem after this is going to put basically number 1 and number 2 together. It's going to be a little different, but it's pretty cool the way it works. I'll see you for that video. Hope you enjoyed.